Right, so we are looking at section 5.5 on page 145. First of all, talking about domain of functions. The domain is going to be all real numbers. It's going to go from negative infinity to infinity. Unless the function contains an even root or is a rational function. Remember, a rational function is a function that has an x in the denominator. For a function with an even root, the value under the radical must be greater than or equal to 0. For a rational function, the denominator cannot equal 0, or else the function will be undefined. So what we have to look at then, if we have any function, a function that's x to the third, x to the fifth, all of those domains are going to be from negative infinity to infinity. The cube root of x, that's fine. That domain is negative infinity to infinity. But if I have an even root, like if I have y equals the square root of x plus 3, for example, whatever's under this radical has to be greater than or equal to 0. So what's the domain going to be here? Negative 3 to infinity, right? So that would be the domain. Those are the only x's I'm allowed to use, are x's that are in this range. And sometimes x's in this range will work if we're solving an equation. We're just now talking about graphing. But if we're talking about graphing, these are the only x values we would be allowed to substitute in. For a rational function, the denominator cannot equal 0 or else the function is undefined. That would be like this. If I have 1 over x minus 2, what's going to make this denominator equal 0? 2. So I would say then my domain is going to be negative infinity to 2 union 2 to infinity. So what that is saying then is that for this problem, I would be able to substitute in any value for x except for 2. I can plug in 1.999 or 2.0001, but I can't plug in the number 2 or else the function's undefined. Scientific notation is not really needed here. So let's look at this first example that we're replacing it with. If f of x equals 4x minus 3 and g of x equals x squared plus 1, find f of g of 2. This does not mean to multiply f and g. A lot of times people think that. They think, oh, shouldn't I multiply f and g? No. What you want to do is work from the inside out. Ignore the f. Find g of 2. Do you know what g of 2 means? Just plug in 2. So g of 2, I plug in 2 for x. What do I get? 5. That's what g of 2 is. So now I'm trying to do this problem. I'm doing f of, what did we just say g of 2 is? So now my problem becomes f of 5. Well, f of 5 means I'm going to look at my f function, and wherever I have an x, I'm going to replace it with a 5. So it's going to be 4 times 5 minus 3. So what's f of 5? F of g of 2 is then going to equal 17. Okay? Now, here's where it gets a little tricky, because people say, oh, if I did f of g of 2, I bet g of f of 2 is the same thing. It's probably 17. Well, let's check into that. F of 2. Go back to your f function, plug in 2. What do you get? What do you get, guys? 5. So now we're doing g of 5. So that means in our g function, we're going to go ahead and plug in the number 5. So if I do 5 squared plus 1, what's that going to give me? 26. So g of f of 2 is 26. All right? That's called a composition of functions. The reason it's called that is because we have a function within another function. So it's called a composition of functions. Now we're going to look at operations on functions. We have f and g are two functions. We can get a new function by performing any of the basic four operations. If you have something that looks like this means the same thing as f of x plus g of x. So if they gave us this for f of x, this for g of x, we would just add those two functions, 6x plus 2. If you see this, f minus g of x, that means f of x minus g of x. Here's f of x minus g of x. Make sure you distribute the negative, and we get this answer. When you see fg written like this, it means the same thing as f of x times g of x. Can you see how that might be confusing? See, look at this, fgx. But look here at the parentheses, fg2. It's a little bit different. This means to multiply the f and g of x. So to do that, we just say 5x times this, and we distribute. This is just division, and so we put this over top of this. By the way, what would be the domain of this resulting function? Negative infinity to, right, okay? All right, so let's do some examples here, something different. We're going to look at another way that compositions can be written. This is confusing as well. We see this open dot. You might think that means the same thing as up here, but it doesn't. This means O, this means of. So this is f of g of x. It means the same thing as this. If I see g, open dot f, that means the same thing. That means of, not times, it means of. So it's g of f of x. All right, so here are two functions, the same ones we had up above. They're asking us to do f plus g of negative 2. That does not mean we add f and g and multiply it by negative 2. What it means is we add the two functions and then we plug in negative 2. It could also mean this. You could do it this way too. Both of those will give you the same answer. I'm going to do it this way, where I add the two functions together. What do we get if we add the two functions together? 6x plus 2, right? And so now, if I want to find f of g of negative 2, I have to do 6 times negative 2 plus 2. And that's going to give me negative 10. All right, so this is going to be the same kind of thing. I can either do f minus g and then plug in negative 4, or I can do f of negative 4 minus g of negative 4. If the negative 4 had been out in front, it would have meant to do f minus g and then multiply it by negative 4. I'll show you that in a minute. But for now, let's do this. So I'm going to subtract f and g. What do I get if I subtract them? 4x plus 2 or minus 2? Minus 2. I have to subtract the whole thing. And so now I plug in the negative 4. So I do 4 times negative 4 minus 2, and that's going to give me negative 18. Now, like I was saying, I'm just going to squeeze this in here. If it had been negative 4 f minus g of x, like this would now mean to subtract f and g and then multiply it by negative 4. So if I subtract the f and g, we already did that, it was 4x minus 2, and then I would multiply it by negative 4. So it's not actually doing these problems that's difficult, it's just understanding what it is you're supposed to do on them. All right, what about this one? Does this mean multiplication? No. This means f of g of negative 2. You guys do it. You should have it. Raise your hand if you know it. What is it? 0 is correct. Did everybody get 0? All right. All right, go ahead and do this one now. This does not mean multiplication. Okay, this is g of f of 3. Another second or two. All right, Alex, what is it? 17. Anybody need to see it? Just raise your hand or nod if you need it. Okay, 17 it is. All right, now this one. Does this mean the same thing as number 3? No. This means what? What am I supposed to do to them? Multiply them, then plug in the number 3. So if I multiply these, I'm going to have 5x times x plus 2. That's 5x squared plus 10x. Now I have to plug in the number 3. So that's going to be 9 times 5, and that's going to be 75. Okay, questions? All right, let's go to the next page. Okay, ready for the next page? All right, let's look at these problems in the next section. It says in exercises 1 through 4, find f plus g of x and f minus g of x, and state the domain of each. Then evaluate f plus g and f minus g for the given value of x. We're just going to switch back and forth. We're going to do plus, minus, plus. I'm not going to do both for everything. All right, so let's look at the first function. We're supposed to add these two together. First, are they like terms? They're both cube root of x, right? So I'd add the coefficients. What do I get if I add the coefficients? 4. So I would write it this way then. F plus g of x equals 4 cube root of x. The domain, I check. Do I have an even root or do I have an x in the denominator? Either one of those two cases? No. So my domain is all real numbers. Now I have to do f plus g of negative 1,000. Plugging in negative 1,000, that's negative 10 times 4, that's negative 40. For number 2, we're going to subtract. You have to be careful when you subtract. It's negative x squared minus 3x plus 8 minus this whole quantity, so minus 6x plus 3. See how I had to distribute the negative through both of these terms? So then I know that f minus g of x is going to be negative x squared minus 9x plus 11. For my domain, do I have to need to change it in any way? Nope, it's just all real numbers, isn't it? So the domain is going to be negative infinity to infinity. Now I have to do f minus g of negative 1. That doesn't mean I'm going to multiply this by negative 1. It means I'm plugging in the negative 1. If it's in front, then it would mean to multiply by it, by the negative 1. It'd be a coefficient. Plugging in negative 1 squared is 1 times a negative. Negative 9 times negative 1. And so 20 minus 1 is 19. Any questions there? Yeah. Oh, I missed the x squared. I just did not see it. Thank you. It's not going to change my answer, though, is it? Oh, yes, drastically. Never mind. Okay, let's fix that up. So that's going to be 2x squared minus 9x plus 8. Now let's plug in negative 1. Negative 1 squared is 1 times 2. That's going to be 2 plus 9. That's 11. Oh, that's weird, isn't it? 11 plus 8 is 19. Okay. Any questions on that? All right, number 4. On number 4, we are adding these two together, so I check to make sure they're like terms, and they are. So f plus g of x is going to be 2 fourth root of x. 1 minus 2 is minus 1. What about on our domain, guys? Is there any restriction? We're taking a fourth root. Can we take the fourth root of a negative? Yep. Correct. We have to be positive if it's an even root. We can't take the even root of a negative number. So there's our domain. Now we're just trying to plug in the number 1. So f plus g of 1, that's going to be just 1. All right, we're just going to do a couple down here. We'll just do one multiplication and one division. Let's do multiplication on this one, and let's do division on this one. All right, so multiplication. We're supposed to do fg of x. That can also look like this, remember, guys. It can look like f times g of x. All right, so now I have to multiply these two things. So I'm going to have negative x to the third times 2x to the 1/3. That'd be a good way to write that. So then I'm going to have negative 2x cubed root of x. You see what I'm doing? I'm just changing this to cube root of x. X to the third would stay out. So now I'm going to go ahead and plug in negative 64. Seriously, I have to cube negative 64? All right, we're not doing that. You know you just plug it in, right? Okay, what about our domain? Do we have any restriction on the domain for that? Nope, because it's just a cube root, so negative infinity to infinity. All right, one more of these type. Number 8, we're going to divide. So we're trying to find f divided by g of x. So we have f of x divided by g of x. What do we do here? What are we going to get? We're going to get a 9. What do I do if my bases are alike? What do I do with the exponents? Subtract. So what's 7/4 minus 2/4? 5/4. So when I divide those then, I'm going to have 9 times the fourth root of x to the 5th. So that's going to be 9x fourth root of x. Now you have to be careful with this. You have to go back here actually and look for your restriction. Okay, you can't look at the simplified. You've got to look, what was it back here? So back here, I would say x has to be positive, but x also can't be what? 0. So I've got to make that. I've got to go back to here for my domain. So I'm going to have to say then that the domain is actually 0 to infinity. I'm not allowed to use 0 because of this right here being a rational function. Now I'm allowed to use this when I want to evaluate with 16. That's not too bad to do. So it's going to be 9 times 16. That's 144 times the fourth root of 16 is 2, so that's going to be 288. Any questions on those operations? So this would be our answer for the simplified version, and then that's when we plug in the number. Okay, get out your graphing calculator if you've got it. So on this one, it's saying the graph of the functions of f of x equals x squared minus 4x plus 4, and g of x equals 4x minus 5 are shown. So they show us these two graphs. Which graph represents the function f plus g? Right. So if I'm looking at these functions, I want to know which one's f plus g and which one's f minus g. What could I do? You could put them in the graphing calculator, since I just told you to get it out. Obviously, that's one way. Would you have to use a graphing calculator, though? No. We could literally just add these and subtract these and see which one it is, right? I want to show you kind of a cool way to do this, though. This is a more advanced way to do it. So what I can do is I can go to y sub 1 and put this in. X squared minus 4x plus 4. I can go to y sub 2 and put in 4x minus 5. I want to know, what does it look like if I add those two? Do you guys remember where I can find y sub 1 and y sub 2? Vars. I go under vars, I go to y vars. I want y sub 1 plus vars, y sub 2. Because I want to add those two together. I want to add f and g. So now, I don't really care what the first two look like. I don't care what that looks like. I don't care what that looks like. So I turn those off, and I hit graph. I'm going to do zoom 6 too. And here's what it looks like when I do f plus g. So I can quickly see that that one is f plus g. Obviously, this one has to be f minus g, but watch how I can quickly do that. Go back to y equals. I've got y sub 1 and y sub 2. Just change this from a plus to a minus. And now hit graph. Takes it a minute to think. And right there it is. And so I can see that this has to be f minus g. Okay? Nice way to do it without having to do even any algebra. All right, last one here. The variable x represents the number of pages of a textbook to be printed. The cost C to print the textbook can be modeled by this equation. C of x equals 0.2x squared plus 10. The selling price P of the textbook can be modeled by the equation P of x equals 0.05x squared plus 20. Find P minus C of x. So they're asking us just to subtract these. So we're going to do 0.05 x squared plus 20 minus, make sure you distribute the negative, 0.2 x squared minus 10, subtracting that whole thing. So if I have 0.05 x squared minus 0.2 x squared, that's negative 0.1, what is that? 5, yep, x squared. And then 20 minus 10 is going to be plus 10. So there is that answer. And then what would P minus C of x represent? If you have your price that you're charging minus your cost, what is it, Molly? That's the money you earned, good. What's another name for that? Profit or revenue, yeah. And in this case, actually, this would just tell us for one textbook, so it's not telling us our total profit or our total revenue. So P minus C would tell us our, we could say, we could even call that profit. Our profit from selling one textbook. Or X, let's call it X textbooks. So if we wanted one textbook, we'd plug in 1 for X, 2, we'd plug in 2 for X, etc. All right, guys, finished with that.